Hi friends, this video we are going to solve this problem. Find the relative maximum and minimum values of the function f of x comma y equal to 2 times x square minus y square minus x power 4 plus y power 4. So we start with, we required two things. One is the gradient of f equal to 0. So what are the points are satisfied? That is, what are the x1 comma x2? It satisfies the gradient of f equal to 0. Those points we called as a stationary points. Then we are going for this is called necessary conditions. So gradient f equal to 0, some certain point. These are called necessary points, necessary condition. The sufficient condition is you want to determine the Hessian of the given matrix. What is the Hessian is? Suppose Hessian matrix H is dou square f by dou x1 square, dou square f by dou x1 x2 and so on, dou square f by dou x1 dou xn. Similarly, dou square f by dou x2 dou x1. This is dou square f by dou x2 square and so on, dou square f by dou x2 times dou xn, dou square f by dou xn x1, dou square f by dou xn dou x2 and so on, dou square f by dou xn square. Okay, so this is the Hessian matrix. This is the Hessian matrix. Suppose this Hessian matrix, all the eigenvalues are positive because it's a function of x1. So it's not a constant, it is h of x1, x2 and so on, xn. So you are positive definite at stationary point, positive values of Hessian matrix. All the eigenvalues of h of x1 star comma x2 star and so on, xn star. It's a Hessian matrix at stationary points or positive means. So this is the first case, positive, then relative minimum. Second is all are negative, then relative maximum. All one of the eigenvalues are 0. remaining all eigen values are positive or negative. So, one eigenvalue is 0, remaining all eigenvalues are positive, or all eigenvalues are negative. Test fails. The fourth condition is one eigenvalues are positive, otherwise some eigenvalues are positive, other eigenvalues are negative. Then the stationary points, saddle points. Okay, so now I am going to, so here only two decision variables x and y. So first I will find the gradient of f equal to 0 vector. So dou f by dou x equal to 4 times x minus 4 times x cube. Similarly, dou f by dou y equal to minus 4 times y plus 4 times y cube. So, I want to say the gradient of f equal to 0 means each component equal to 0. So, this implies 4x minus 4x cube equal to 0. This implies x equal to 0 or x equal to 1 or x equal to minus 1. So, from this guy minus 4y plus 4y cube equal to 0. This implies y equal to 0 or y equal to 1 or y equal to minus 1. So, from this, so we have the stationary point nearly. So, what are the points are stationary points? X is 0, y is 0, x is y is 0, x equal to 0, y equal to 1, x equal to 0, y equal to minus 1, then x equal to 1, y equal to 0, x equal to 1, y is 1, 1 minus 1, then minus 1, 0, minus 1, 1, minus 1, minus 1. These 9 points are stationary points. These are stationary So now I want to find the Hessian of each point. So to find the Hessians, we require the second derivative, dou square f by dou x square equal to 4 minus 12 times x square dou square f by dou xy equal to dou square f by dou y, dou x, both the values are 0. So, dou square f by dou y square equal to minus 4 plus 12 times y square. So, now this is the h of x comma y. Four minus 12 times x square 0 0 minus 4 plus 12 times y square. Now, so I want to apply h of 0 comma 0. This is my first stationary point. X equal to 0, the first entries become 4, 0, 0, y is 0 means minus 4. So, it is a diagonal matrix. So, diagonal matrix, the diagonal entries are the eigenvalues. So, eigenvalues are four and minus 4. So, this implies 0 comma 0 point is saddle point. Since the given matrix has one positive eigenvalue, another one is negative eigenvalues. So, second stationary point 0 comma 1. So, I want to calculate h of 0 comma 1 equal to x is 0. So, 4 0 0 minus 4 plus 12. So, it will get it as 8. So, the same idea, the eigenvalues are for this matrix so 4 and 8. So, this implies 0 comma 1 is relative minimum. Minimum point. So, h of 0 comma 0 comma minus 1. This matrix also you will get the same matrix 4 0 0 8. So, the same thing only will come. The eigenvalues are 4 and 8, and then 0 comma minus 1 is relative. So, the same thing. Okay, eigenvalues are 4 and 8. And 0 comma minus 1 is relative minimum. Next is I want to calculate another stationary point is h of 1 comma 0. So, h of 1 comma 0 means, so our matrix is, this is 1, so 4 minus 8, 4 minus 12 is, we got it as minus 8, 0, 0 and minus 4, because y is 0 means minus 4. So, eigenvalues are minus 8 and minus 4. So, this implies 1 comma 0 is relative maximum. Some people they call it as a relative maximum as locally minimum or local maximum. Okay, relative word they can change to locally. Next is h of 1 comma 1. If you are getting, you will get it as minus 8, 0, 0 and 4 minus plus 1 is, again you will get it as 8. So then one eigenvalue is minus 8, another value is plus 8. So this implies eigen values are minus 8 and plus 8. So this implies 1 comma 1 is saddle point. H of 1 comma minus 1. So the first one is minus 8, 0, 0 and 8. The same thing only will come. Eigenvalues are minus 8 and plus 8. This implies 1 comma minus 1 is again a saddle point. Next one is, next 3 points is h of minus 1 comma 0. H of minus 1 is, so plus 1 only will come. So 4 minus 12 is 8, minus 8, 0, 0, we will get it as minus 4. So eigenvalues are minus 8 and 4. So this implies minus 1 comma 0 is relative maximum. H of minus 1 comma 1 minus 8, 0, 0 and 8. So clearly eigenvalues are minus 8 and plus 8. So minus 1 comma 1 is saddle points. H of minus 1 comma minus 1. So first row is minus 8, 0. Second row is 0 and 8. So the same thing. Eigenvalues are minus 8 and plus 8. Then minus 1 comma minus 1 is a saddle points. So what is the question? Find the maximum minimum value of the given function. Okay. So where is the minimum values occur? So what are the points is relative minimum value occur? I want to check it. This is h of 0 comma 1 is the minimum. So 0 comma 1 as the minimum will occur, and 0 comma minus 1 and 1 comma 0 is maximum, and minus 1 comma 0, and so these are the 4 points are the relative maximum, relative minimum we get it. So those points are 0 comma 1, one is relative minimum and 0 comma minus 1 is relative minimum. So relative maximum is 1 comma 0 and minus 1 comma 0 is relative maximum. Now you look, our aim is I want to find the maximum minimum value of the function, not the extreme points they didn't ask. So we have to evaluate the function value. F of 0 comma 1 is x square is 0, so minus 2 plus 1 equal to minus 1. F of 0 comma minus 1 equal to minus 2 plus 1 equal to minus 1. So the relative minimum value is minus 1 only, and f of 1 comma 0 is 2 plus minus 1, so 1 only will get. F of minus 1 comma 0 also 2 minus 1 1. So the relative maximum is 1 and relative minimum is minus 1. So relative maximum of the given function is 1 at 1 comma 0 and minus 1 comma 0. Relative minimum of the function of the given function is minus 1 at 0 comma 1 and 0 comma minus 1. Remaining all stationary points are saddle points. I hope you understand how to find the stationary point, then using the sufficient condition how to find the maximum or minimum of the stationary point. Thank you for watching this video.